So this is in Rhino. The first thing we're gonna do is run Grasshopper, right? So you can type Grasshopper if you load this magnificent plugins, my favorite plugin. So it basically provide call this graphic interface for scripting. So it just allow you to link the component. You can execute and you can get the result. All right, so instead of start from scratch, I will just open a file I already built. So just explain a little bit the logic. Then we can start from scratch. So first thing, I will open a Rhino file. I have to want to reinforce Rhino file and Grasshopper file, they are independent. Okay, so you want to save both files, otherwise it won't work. So here in Rhino, I will open, let me just open the recent. Okay. Later I will put both Rhino file and Grasshopper file in OneDrive, so you can get all of these example files. All right, this Rhino file is relatively simple, right? I just create a hexagon, which is done through the the tools here, which you all know. Because I read a paper about Islamic pattern, right? I want to create something kind of follow this logic. You could start with a triangle or pentagon. I will just start with a hexagon because it's easier to create repetitive patterns out of hexagon. It's like a beehive, right? We all know beehive is repetitive. So here, before I do any Grasshopper script, you just want to testing some ideas. It's good you go through this in Rhino manually first. So here I did a hexagon. I copied this hexagon here, because I'm thinking in the future, if I want to create an array, right, a grid, it's hard to manage a grid in hexagon, because sometimes this angle is not like a rectangular corner, right? You cannot meet the next one precisely in this corner. Instead, it has, if you have two hexagons overlaid here, then the next one you can have a copy, which is based on the rectangular grid. So here, the next grid could be based on the rectangular from here to here. See? So that's how you got this duplicated array. So that's some kind of thinking in the early on. I want to start to think about how kind of repetitive pattern was created. Another thing I thought about this in early on is really look at the variation. There is a lot of symmetry here, right? So you don't really need to create something from like a circle first. Instead, I can concentrate on a kind of slice, like a pizza, right? I can just concentrate on one slice. And then this slice later can be duplicated, right? Can be array along the center point. So that will save you a lot of time if you think about the strategy. You break down this problem into smaller problems. So in this case, you can see this is actually a pattern. It looks like a triangle, right? And this triangle has a point kind of moving along this green axis. That will actually push this triangle, make it as a very fat one or a very sharp one, right? So this is a variable, which is kind of traveling along the axis. So that's a logic. You could actually recreate that kind of star shape. So here in Rhino, I start to think about, well, if I want to define this kind of changing variables or these kind of moving points along this axis, right? How I can define this point. So first, I create this supporting line, which is based on the middle point and the center. I create this kind of track or trail. And then I can see there's one point could travel along this trail, right? From one end to another. And then this is two arms can be generated. So as a result, you have this kind of triangle, which could be fat, could be narrow, depends on how far this point travel along the track. Does that make sense? So this is kind of parametric the thinking without Grasshopper. You need to sometimes you do this on paper, sometimes you discuss it with your friend, just figure out what's the logic behind this pattern. Then we'll talk about how we can actually make this parametrically. Right? One thing to start out is you don't have to remove all the geometries, just leave all the geometry there, because this geometry actually provide a very reasonable called the reference lines for you to use in the future. So here I will just go ahead, open my version. I will explain a little bit. So this is my version. Of course, I already did all the scripting. I already created a script of this user interface. This is the part of Grasshopper. If I hide this script and I just using this controller, I will tag my full screen. So you can see this is the controller. So just imagine I'm that young, architects know how to program. You guys are the manager, right? So you, as a manager, this is the interface you're gonna see. You'll see, wow, this is pretty cool. What this can do? Then you can say, hey, sir, I can do something for you in a few seconds. So first, I can drag the depths, so I can see the pattern will be, changed. Just let me know which one you like. I will pause. Right, so you can see all the variations is embedded here, and also say, hey, I can also change the thickness. So if you're gonna cutting this to aluminum instead of plywood, they maybe have a different thickness preferred. So here I can say, hey, I can get a really thin one, or I can get a really fat one. Tell me which one you like. Then we can freeze it, we can bake it, we can send to laser cutter. That makes sense. So that is the kind of end result you can deliver to your manager. Yeah, that's the one way you can think the benefit to use the script. So here, let me explain a little bit about logic. So first, I will disable the window. Okay. So you want to see the window pop up. I will just explain a little bit, just step by step, what I have done. Okay. Of course, this requires you to watch this later and maybe reconstruct by yourself from scratch. So here is just going through the logics. And if it's the first time you use Grasshopper, I will just turn on the green bucket. This means you only see the things in selection. So if I select this or that, really depends on which component I selected. You will see the green line will show up. Right, the green line basically is indicate what is the result of that particular operation gonna give you. Right. So let me go through this from left to right. That is how the script works. Let me just plug in something really quick before we going through it. Okay. So let's start from scratch, from this part. Okay. So the first thing I do is I loaded a curve, okay, which is this trail, this track, this 45-degree track into Grasshopper. This is how Rhino communicate into Grasshopper. Then I create this guy. The name is evaluate curve. Which you can hold Control Alt Shift and see where this component come from, or Control Alt. Okay. So basically, if I click this guy, you see a green point show up here, right? If I drag this slider, do you see this one travel from one end to another? Okay. So this is called evaluate a curve. The T point is what we call the T value, is indicate the position of a point along a curve. Okay. One trick you want to make sure the curve is this one has been re-parameterized. The reason is sometimes if the curve is came in from Rhino, it doesn't necessarily count 0 in one end, 1 in the other end. So if you re-parameterize, it will force Grasshopper to add 0 for one end and 1 for the other end. So when you do this kind of slider, right, it will travel between these two ends. All right, so I have these new points. And after I have these points, I loaded another point from one center here, another point from the other center here. So I create the first line. You can see the green line here, second green line here, and I merge them together. So basically, what this do is, if I move this t value again, you have this kind of triangle being generated. Right? So that's exactly the same logic as the paper showed you. Question?
How to make the component show the logo and not the name?
Oh, that's a good question. Just display icons. Yeah. Yes. All right. So you have this as a triangle now. Then I join these two curves. So they became one curve. That's pretty easy to do, right? Same thing as Rhino. And I did offset. The reason I want to do offset, if you compare, this is the original, this is the offset version, is you want to create a thickness, right, of this pattern. And also this pattern should allow some space overlapping along the corner. So when you laser cut, it just punches the holes. It doesn't break apart this individual cell. So you do need a little bit thickness to it. So I have the thickness offset from one side. Then I trimmed this thickness with this bigger triangle. You can see it show up as a red color, as a green color. I know it's a little bit hard to tell, but it's basically, this is a cutting triangle. Okay. So the cutting triangle and offset number, will be compute. Then you have the result, right? So it's offset in one direction, then cut it. Same thing, I will offset the other way, and I cut it. So as a result, I have this thickness. And if I drag my t value, you see this one still travel. Pretty cool, right? But it's within the triangle, right? The rest part is relatively simple. Once you have the form, merged as a two offset, I made an array. So this is called polar array. The array based on a center point. So that's a star shape. Right? And also I did this kind of duplication from this corner to this corner. Okay, so this is done by use this component name is orient. It's moved from the 0, 0 to this new location based on two center point. And after I made a duplication, I made an array along the x-axis. So that here. You can also control the number of array. Right now it's 4, but you can do more. Flexible. This value control the distance of array. This you have to be careful because you have to make a measure in distance, right? In Rhino, make sure this precisely reflect the center to the next center. Right? You have to make an adjustment. If it's not this, you will see the array kind of overlapping like that. Okay. So I made X array, then I did the Y. So that's you got both directions. So that's how you create this Islamic pattern, just with a simple grasshopper script. And here, as I said, you can still drag the t value. You can see the change, right? That's pretty cool. So this is all done in a kind of programmer mindset. But the challenge we're going to present to a manager, right, who don't know computer. That's the reason in the second half, I use a script. This is actually designed with a component name is human UI. It's right here. Later in the project E1, you can see the download link. You can download these plugins. They are the plugins for Grasshopper. So this human UI allow you to create a window, pop-up window. And this window allow you to create a slider. Okay. And this slider will display. So here, if I double click true, you'll see this window show up. Right. It's a little bit transparent, but I think you can see it, right? it will pop up. It has sliders. This slider, basically, if you drag, is disconnected right now, but it's okay. So when you drag the slider, so this value is actually fitted into Grasshopper. So right now this is between 0 and 1. I give the name to depth. Another slider, I gave the name of the thickness, from 0 to 1. So you can actually define the value right here. Then I can merge this as an interface elements and put into the window. So that's how it hosts these variables as a slider inside the window. Okay, but right now there's no communication between this window to the Grasshopper script I just wrote, because the t value right now is controlled by the slider, right? So if I do want to make this window, this slider, the new slider pop up in the pop-up window to control, I basically need to do is to link this variable. Okay, this is controlled by the pop-up window slider. I want to link this number into the t value instead of use my default Grasshopper slider. So this is a new one come from the pop-up window. So I use it to replace it. The same thing for the thickness. Here the thickness pop-up window slider, which is here, which is linked into this number. Right now I'm not using it, but I'm going to use it to replace the offset. Okay, replace offset. The reason you see a star here, if I right click, I did the expression is -1 multiply x. So basically it just put whatever value here as a negative into offset. So it's offset in one way. And this is a positive, it offset on the other way. So it's offset both ways. It just save a little bit time for programming. So since we connected both pop-up sliders into the Grasshopper script, now if we run this again, you can double click true. Okay, this button is actually just toggle the full screen. Oh, the reason it doesn't show up is because we hide everything with a green bucket. So we want to actually disable that, so it will show everything all together. If you click, it only show the selected stuff. So disable it. Now we have this beautiful script. Then I can drag it. So this slider now communicate through the pop-up window into my Grasshopper script. That makes sense? So this is a kind of create like alternative way you can do the pattern, right? There's unlimited possibilities here. If you like, I like this version, for instance, then I can go here. Right, this is the result. I can right click and bake it. Right. In Grasshopper, bake means you transferred the model from Grasshopper into Rhino. So bake to number 5, and then I can toggle screen. I can close it. I can close it. You can see everything will be saved in layers 5 right here. So it's physically embedded in Rhino. Okay. All right. So let me stop my video.